Hi everybody, welcome back to the Feynman Technique. Today we're going to be solving this parameterized integral right here. This relates back to the result we got in our previous video. We will be using that result to solve this one. But this structure appears frequently in things like physics, chemistry. It's used in diffusion and probability theory and things like that. Um, but let's just get started with it. So our first step is to treat it basically as a function of b. That way we can differentiate it. But first, let's notice that if we plug in b is equal to 0, we recover a form that we already know from our last video. If we plug in b is equal to 0, you'll see that all we are left with is this. And we found that that's equal to the square root of pi over 2a in our last video. All right, so next we're going to differentiate our integral with respect to b using the Leibniz rule. All right, so if we apply the chain rule, that partial derivative becomes this. And then that simplifies to this new integral right here. And now we're going to go back to our original I of b and perform a substitution. We are now discarding this part, right? Not discarding it, but we'll take note of it. But we're going to perform a substitution on our original I of b, and that is u is equal to b over ax. And that implies x is equal to b over au. And dx is negative b over a u squared du. Plugging that into our original I of b, this is the equation that we have. And you'll notice that it is, well, let's do some simplification first. We'll notice that this a squared, all this junk right here, which is right here, just simplifies to this. So now our original I of b can be expressed like this. And you'll notice that this is pretty much just a constant multiple of our I prime of b. You'll note this is exactly negative 2b times a over b times I of b, which simplifies to just negative 2a I of b. So now we have a differential equation that's fairly easy to solve. We divide both sides by I of b, take natural log on both sides, or I'm sorry, integrate both sides. And we have I of b is equal to some constant times e to the negative 2ab. Now we know that I of 0 is equal to, we know that I of 0 is equal to square root of pi over 2a. That means that c has to be square root of pi over 2a. So finally, we have our answer to our original integral I of b right here. So this integral right here evaluates to square root of pi over 2a, all times e to the negative 2ab. All right, guys, hope you enjoyed that, and we will see you next time.